Unit 4, Quadrilaterals and Polygons, Lesson 3, Rectangles. Your objectives for this lesson are to identify properties of rectangles as well as to apply properties of rectangles to solve problems. Okay, so a rectangle, I'm sure that you've seen this before, is a quadrilateral with 4 right angles. So A, B, C, D is a rectangle, and you see the boxes in the corner symbolizing that each one is a 90-degree angle, a right angle. Rectangles are a special type of parallelogram, so they have all of the properties of parallelograms that we looked at in Lesson 2. The opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles add to 180 degrees. They're supplementary. And the diagonals bisect each other. In addition to this, 2 special properties of rectangles are that all 4 angles are right angles, so 4 90-degree angles, and the diagonals are congruent, so they are equal to each other. Example 1, quadrilateral RUTS is a rectangle. If US equals 6x plus 3, so where's US? Right here. Nope, sorry, this way. So this is 6x plus 3, the whole thing. And RT equals 7x minus 2, find x. Well, US and RT are the diagonals of my rectangle. And as you just saw down here, the diagonals of a rectangle are congruent. So if I want to find x, all I have to do is set those equal to each other. And I can do that again, since those are congruent, I can write an equation using the 2 diagonals. So for this equation, I want to get all my x's on one side, just like always. Let me subtract 6x. And on the left side, I'm left with a 3 equals 7 minus 6 is 1x minus 2. Now to get the x by itself, I need to move the 2 to the opposite side. Opposite of subtraction is addition. So we get my 1x, or x, equals 5. Okay? And that is the answer here. Example 2. Quadrilateral RUTS is a rectangle. If the measure of angle STR equals 8x plus 3, so STR is right here, this is 8x plus 3, and the measure of angle UTR, so that's here, is 16x minus 9, find the measure of angle STR. So we want to actually find that as a number. Well, let's think about, what do we know about rectangles that we can use to solve this problem? I know that each of the 4 angles is 90 degrees. So really, angle STU, which is the whole angle, red and blue together, is 90 degrees. So I can use the angle addition postulate to find x. I'm going to say 8x plus 3 plus 16x minus 9, so that's the red angle plus the blue angle, equals 90 degrees total. Now I'm going to combine my like terms to solve for x. So I get 8 and 16 is 24x. 3 minus 9 is a negative 6, equals 90. Next step, I want to get my x's by themselves, so I'm going to add a 6 to both sides. And we have 24x equals 96. Last thing to do, divide by 24. And x equals 4. Okay, but we didn't want to find x really. We want to find STR. So that's my red angle here. So let me take that x equals 4 and plug it in. So I have 8 times 4 plus 3. 8 times 4 is 32 plus 3 gives me 35 degrees. Okay, and this is the measure of angle STR. Example 3. Quadrilateral ABCD has vertices A, -3, 0, B, -2, 3, C, 4, 1, and D, 3, -2. Determine whether ABCD is a rectangle. So we're going to do this two ways. This is a coordinate proof. Just like the one in lesson 2, method 1, we're going to use the slope formula. And we want to show that this is a parallelogram, so opposite sides have the same slope. And we want to show that the special type of parallelogram is a rectangle, so the consecutive sides are perpendicular. Okay, so slope formula is m equals y2 minus y1 over x2 minus x1. And I'm going to label x1, y1, x2, y2. Okay, so let's start off with BC. My slope of BC, I see y2 is 1, minus y1 is 3, over x2 is 4, minus x1 is a -2, minus negative is plus positive. 1 minus 3 is a -2, 4 plus 2 is 6. So the slope of BC is -1/3. Okay, now we're going to find the slope of the opposite side, because if it's not the same, then it's not a parallelogram, meaning this is definitely not a rectangle. So y2 here is -2, minus y1 is 0, over x2 is 3, minus x1 is -3, minus negative plus positive. -2 minus 0 is -2. 3 plus 3 is 6. Again, this simplifies to -1/3. These are the same slope. That's good. Okay, so the opposite sides here definitely have the same slope. Let's check on our other pair of opposite sides. So AB, my slope is going to be 3 minus 0, so y2 minus y1 over x2 minus x1. And this simplifies to 3 over -2 plus 3 is 1. I'm going to leave this as a 3 over 1. Last up, CD. Moving both of these. Oops. Okay. y2 is 1 minus y1 is -2, so plus 2, over 4 minus 3. This gives me 3 on top. 4 minus 3 is a 1. Good, so these are the same. We definitely have a parallelogram because the opposite sides both have the same slope. Now, I'm going to compare. I'm going to look at angle B here. So I want to look at AB and BC. And I know that if these are perpendicular lines of right angle, then the fractions should be flipped, and they are. So I have a 1 on top, 1 on bottom, 3 on top, 3 on bottom. And the signs should be changed. So this is a plus, that's a minus. That means that these are perpendicular lines. They meet at a right angle. And if I were to compare then AB to AD, I see that it's the same number. So AB and AD also meet at a right angle. And then if I compare AD to CD, I just change from 3 over 1 to 3 over 1. Again, that will also be a right angle. And then if I move this back up here, I just change to the same number from -1/3 to -1/3. So I have 4 right angles. So let me write my conclusion, and I'm going to type it for you. So since the opposite pairs of sides have the same slope, they are parallel. And maybe I should say both pairs. So since both pairs of opposite sides have the same slope, they are both parallel. Therefore, ABCD is a parallelogram. Not doing such a great job typing today. Okay. Since consecutive sides have opposite reciprocal slopes, they are perpendicular. This means that ABCD is a rectangle. Okay, that's my conclusion. Now, we're going to do this again. And this way I think is longer. So I prefer the first method. But you can, if you really hate the slope formula, use our second method, which is the distance formula. I just think that this way is a little bit more work. So just like before, we're going to start by finding the side lengths. So all 4 side lengths, and we want opposite side lengths to be equal. We're going to use the distance formula for this, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Going to label x1, x2, y1, y2. So my distance for BC is going to be the square root of 4 minus -2, so plus 2, squared, plus 1 minus 3 squared. So 4 plus 2 is 6. 1 minus 3 is -2. This gives me the square root of 36 plus 4. These numbers should both be positive. If you got a -4 here, then you forgot to put parentheses around this when you put it into your calculator. So I have square root of 40 for BC. Okay, let's find AD. It should be the same length. Move my labels. So I have x2 is 3 minus -3, so plus 3 squared, plus -2 minus 0 squared. And 3 plus 3 is 6. -2 minus 0 is -2. This should look familiar. So I have 36 plus 4 under my radical, which gives me square root 40. Square root 40. Okay. Now those are the same, so that's good. If they weren't the same, I would want to go back and check my work because in a parallelogram, opposite sides are congruent. We're going to find AB next. So I'm going to change to blue for my two new sides. AB equals the square root of x2 is negative 2 minus x1 is negative 3, so plus 3, and 3 minus 0. Okay, so I have negative 2 plus 3 is 1. 3 minus 0 is 3. So this is the square root of 1 plus 9, which is the square root of 10. So this is square root 10. Let's check and make sure that CD is also square root 10. So I'm moving both of my labels. And I'm going to move this up so I have some space to work. So CD is the square root of x2 is 4 minus x1 is 3 squared plus y2 is 1 minus y1 is negative 2, so plus 2. 4 minus 3 is 1 squared. 1 plus 2 is 3 squared. So I have the square root of 1 plus 9, which is the square root of 10, and by golly, they match. So AB and CD are both square root 10, but that's still not proven that we have a rectangle. All we've proven so far is that we have a parallelogram. Next, and you may have noticed that these are up here, they weren't in the last diagram, we're going to show that the diagonals are the same length, because in a rectangle, the diagonals are the same length. So I'm going to find BD first. I'm going to change to green for my diagonals. So BD. X2 is negative 2 and X1 is 3. So I have negative 2 minus 3. And let's see what y2 is. 3 minus negative 2. So 3 minus negative 2 is plus positive 2. Negative 2 minus 3 is negative 5 squared plus, this is a positive 5 squared. Square root the whole thing. Okay. And negative 5 squared gives me a 25, as does 5 squared. So I have the square root of 50. Okay, what's the last thing we have to find? We found BD, let's find AC. Okay, so AC, hoping that it's square root 50, so we didn't do all this work for nothing. But it should be since our last part 1 worked out. So, where are we? X2 is negative 3 and X1 is 4. So I have negative 3 minus 4 squared plus, what about my y's? Y2 is 0, Y1 is 1. So 0 minus 1 squared. Okay. Negative 3 minus 4 is negative 7. 0 minus 1 is negative 1. When I square these, they will both become positive. So this is the square root of 49 plus 1. And that gives me the square root of 50. Yay! Okay, so let's write a conclusion. Since the diagonals were the same, this is a rectangle. So I'm going to say, since opposite pairs of sides are congruent, ABCD is a parallelogram. Since the diagonals are congruent, ABCD is a rectangle. Okay, and that is my conclusion here. Okay, and that is the end of lesson 3.